Hey everybody, Mr. Kirkwald here. So today we're going to get into our last section of light notes, and so we're going to go through that now. So we're in May 27th. You saw the video here. Just like we've been doing, we're going to have our light notes up too, and then we're going to do that. So here we go. We'll start with mine. So this is our kind of second set of light notes. This is going to give us a couple more vocabulary words and a little bit more information about light. So on here, you'll see yours are all messed up, but the colors we see. So we can see red, orange, yellow, green, blue, indigo, violet. Talked about Roy G. Biv last week. So we can see all of those colors. A reminder that red light has the lowest frequency, and then as we go up from red to orange to yellow to green to blue to indigo to violet, we'll see that the frequency of those waves gets smaller, or sorry, not smaller frequency. There's a larger frequency, so we're having more and more waves in that same amount of space. So our frequency is going up as we're getting as the colors get a little bit darker. So take a minute to put all those in the right places. Hopefully everybody can do that. Slide 3. What is light? So we know that light is a type of electromagnetic wave. Sometimes we abbreviate it to EM. We talked about how that scientists really like big words, so they say electromagnetic, but sometimes they don't like to write them very much, so they abbreviate it to EM waves. So, and then electromagnetic waves are waves that have an electric and a magnetic field. So they've got two things going on there. So light waves vibrate perpendicular to the direction they're traveling. That's a fancy way of saying that they're moving up and down transverse waves. So think waves in the ocean, right? Up and down, up and down. Not like sound waves. Sound waves kind of travel in a line. We talk about like the slinky pushing it. So these ones are going up and down and up and down. And then light does not need a medium to travel through. So light can travel through space. That's why we can see stars and everything, because that light can travel without any medium. Just keeps going forever and ever and ever. So let's talk about a couple vocabulary words here about light and kind of how we see it. So we can see light doing a couple of things. The first thing is the word reflection. So reflection occurs when waves bounce off an object. So if you're looking at yourself in the mirror, the light waves are bouncing off the object and then coming back to you so that you can see yourself in the mirror. Refraction, so reflection, refraction. Refraction occurs when a wave bends as it passes from one material, oh my gosh, from one material to another. So occurs when a wave bends as it passes from one material to another. So this one, we have light hitting a prism and then it's kind of being angled down. The best thing that you can remember for refraction is if you're ever trying to like catch a fish underwater, if you see like a little perch or something swimming while you're at the lake, you try and grab it, but it's not actually there. Usually they're too quick anyways. But even if you're trying to use like a spike or something like that to actually get the fish and so you can eat it that night, it's not actually where it is. If you stick your stick in the water, you'll see that it actually is in a different spot. And so with refraction, what's happening is the light goes into the water, but it's actually bending. You can see the same thing with your straw in water. So if you have a straw in a water cup, you'll see that the straw looks like it's kind of broken when it gets to the water, but that's because of refraction. So when you pass from one material to another, from air to water or something like that, that's when that kind of bending of light is going to happen. And then diffraction occurs when the direction of the light changes when it comes to an obstacle. So, for instance, if you poke a hole in an index card, just like I have it here, you can see the light through that, but you can also see the light around the index card. So you can see the light is bending around the index card once it gets there, so that way it's still visible to you, but it's more visible if it's in a straight line instead of going around it. So we've got reflection, refraction, and diffraction. There we go. So we got 3 more words here, so I know we got a lot of vocab today. So Objects can be one of three things. They can either be transparent, translucent, or opaque. Now, transparent and translucent are different. Sometimes they're used interchangeably by people, but they're actually different from each other. So transparent is matter that allows light to pass through the objects. You can see through it. So your windows in your house, you can see through those objects or that glass, and so that is a transparent object. So I put a picture of a light bulb here because a light bulb, this one in particular, we can see through the light bulb and see everything inside of it and then out the other side even. So transparent objects we can see all the way through. Translucent objects transmit light but not really an image. So if you take a look here, it's kind of some fogged glass. We can see that that's probably a tree, but it's not a distinct image. So the light is passing through, but as it's passing through, it's being scattered and bounced around so much that we can't see what image it is, but we can see that there's light traveling through. So that's a translucent object. It's like you can kind of see it, but not really. And then last but not least is an opaque object. So this is matter that you cannot see through. So I can't see into this lunchbox here, so I don't know what's in it. So opaque objects is everything else. So probably the couch you're sitting on, hopefully you can't see all the way through it, or things like that. The walls, those are opaque objects, matter that you cannot see through. And last but not least, opaque objects. So some colors and opaque objects are absorbed and others are reflected. This is how we can see different colored things. So for instance, right here, why is this apple red? Well, it's red because the sun is giving off all the colors of light at once. So all of the colors of light are being blasted out from the sun. That's why it looks white, okay? Or light bulbs look white inside of our houses. That light is all the colors put together. So it's a little bit different when you're mixing all of your paints, and you're like if you are using watercolors and you paint all over the paper and then you use a different color, it starts to turn black in your water cup. So this is the exact opposite. When all the light is together, it's actually white, and when there's no light at all, it's black. So all of the light is coming into that object, and then when it hits that apple, the apple absorbs. So it absorbs the red, it absorbs the green, and it absorbs the blue, it absorbs the yellow, all of those different colors, and then it only reflects off of, just like a mirror, bounces off of with the color red. And so there's a whole big, I don't want to get too far into it, but so there's objects, we talked about how atoms vibrate and things like that, and so that vibration interacts with the vibration of the light waves, and so that's how we get the different colors, okay? So with a Granny Smith apple, if it was green, that means that the red is being absorbed, the blue is being absorbed, all of those colors. So that's why you want, or like if it's summertime, you're a lot hotter in a black shirt than you are in a white shirt, because in a white shirt, all of the waves are bouncing off of it and all of them are reflecting off of it. But in a black shirt, all of those colors are being absorbed by it. Nothing's being reflected back. So just a helpful little thing there. So we've got all of this stuff down. That's all for today. And then I'm super excited for tomorrow's activity. So I will see you guys later. Bye.